Well, now I want to talk a little bit about morphology and something that I think has been missing from the discussion. So if we can conceptualize a sandy ridge formed by wave momentum and a backbeach swale filled with runoff. So let's take this brown as being the ground surface. And this is kind of an isometric, you're kind of looking down at the, like from a little plane or something. And here's your ocean out here, these little blue lines, and your shore. And let's say this is the lagoon, you know, and it's got, I don't have the ends on either side, and then this is upland here. So we have water in the lagoon, or the lake actually, the way it is now, and then we have the ocean water. So what happens is the waves are, you know, kind of energy moving through the water. And as they break, their momentum is transferred into setting the water up and taking sand and pushing it up. So that's why the beach comes up and you have a berm. So, you know, different from just considering gravity where everything would be flat, our equipotential surface is actually a slope and a berm. That's why we have beaches. And besides eroding beaches, waves actually build beaches. And that's why the berm is there. And also when you have a dry sand beach, the wind can then take some of the finer sands and blow that and make dunes. And so the equipotential surface is not flat, it's a beach and then dunes, as long as those processes can continue. Now what happens is you get runoff coming down from the land and it can't get through that berm. The waves build that berm and it takes a lot of power to get through that. So the water pools in the low areas, in the swales. And then occasionally the runoff the rainfall, you know, it rains really hard, it's been raining for months, and the water gets really high and it breaks through the berm and it discharges. It finally has enough power and elevation to break through the sand, pipes, anyway, there's a whole other number of mechanisms and get it going, but it discharges. And then the level lowers, and then the waves build the berm back up and it shuts off. Now, native vegetation and animals have evolved to thrive in the natural dynamic system, but are threatened due to our mismanagement. These things don't happen anymore at Laguna Salada, except for the flooding parts and maybe the erosion parts, because we've impacted the system, we've constrained it so it can't react, it can't function. And that's the biggest threat to habitat, is that we've taken what they have evolved to live in and we've changed it. And it's, so, you know, further, you know, seawalls and revetments and pumping and stuff isn't necessarily the right approach to deal with the problem. Next slide, please. So let's talk a little bit about coastal flooding. Also something I don't think people have talked about much. There's not really an animation, but if you just click it once. So this is looking at what I was showing you, but looking at it sideways, what we call a profile, right? So here's the ocean, this literal barrier, beach and dunes. It's kind of scrunched and exaggerated so you can see it. And then this little back beach area and then the upland here, conceptually. And so the ocean's out here. So when we get a storm, we get this storm surge and setup. And this is what I meant by still water level. It's like you got a high tide and El Nino and the wind's blowing and all this stuff, so the water's higher. Next slide. Then you have waves in the storms. Next slide. And the waves erode the shore. So you get this what we call event erosion. Next. And then you get waves coming up, running the run up and the overtopping. Next slide. And then you get flooding on the inside. So that's kind of the vernacular. Next slide. So and then let's talk a little bit about sea level rise. So what we call shore transgression with sea level rise, the natural shore is maintained by shifting up and inland if it's unconstrained. You don't actually, if you have enough sediment it's unconstrained, you don't lose the beach with sea level rise. Next slide, please. So we have all this stuff. Instead of a storm, we just have a kind of a complete sea level rise and storms on top of it. We still have wave overtopping, and then you get sand transport. So waves overtop, and this is a conceptual drawing. Next slide. And so then what happens is that momentum at a higher level takes the shape roughly that you had before and just moves it up and in. And so what we had out here and we now have up here, so we still have a beach. So with sea level rise, we still have beaches and dunes and habitat and everything else. The lagoon gets a little smaller. And if you have a flat slope here, your wetland can migrate and transgress also. So this is called thinking this is the way nature would adapt to sea level rise. Next slide. So what we do is we build this little levee here, like this little thing, and put it right on the top of the sand. And we think, oh, okay, now I can build my house right down here. Boy, I'm looking good. But maybe just it's high enough that I can see the ocean, but not, just right there. Okay, next slide. But, we have sea level rise, and we get the waves, and next slide. And then what happens? You get erosion. So you have long-term erosion, which removes the beach. See, now if you hold the line and you don't let the sand over, this is going to erode even more. So you have no beach, and you can just go out to Sharp Park north of the pier and see what you get after 30 years. You get rocks. You get no beach. There's no beach, hardly. And then you have the hydraulic on the loading on the levee increases because it's deeper. The breaking waves are bigger. Waves runs up higher. Levees, revetments, seawalls, they start to fail. You have to put more money into it. It's very, very expensive. Very, very expensive. And then the interesting thing about this is by holding the line here, you're essentially, over time, as the ocean tries to move in, up and in, you're essentially moving out. It's almost like, well, we'll build a levee here, and it's kind of like in 50 years, we'll be out in the surf zone. So what does that feel like? What happens is you get water pumping over the top of this thing, and it can't get out. So, next slide. You actually increase your flood risk. And the flood risk is the integration of not having a beach here over time to dissipate the energy, foreshortening the distance over which the wave momentum is dissipated, creating a very brittle system so when it fails really strongly and rapidly, catastrophically, like in Louisiana. And then you get all this water over here, and at the same time, the other part of the risk is everyone thinks, oh, this is cool, we got a levee, and we're all safe, and they're hanging out right down here, and they're underwater. So this is where we're headed with the management scheme that we have. This is the part that people aren't talking about.